Welcome, everybody, to Stay Curious. I'm your host, Mark Marquette. So glad that you joined us today with a very special guest, the uh, one of the bosses at the company that we talk a lot about, Vaya Space, our hometown rocket company here, CEO Kevin Lowdermilk. Kevin,
Thank you, sir. Happy to be here.
well, we're glad to have you here. Been trying to get Kevin here for a while, but things always happen when they do, and this is a great time. Glad we waited because a lot of things are going on at Via Space. We've talked about them and had some of your young engineers on here over the years, thanks to Mary Baldino and Sean Mursky there.
hmm
Stay in touch. And I do see Kevin, we run each other a few times a year, if not more, at some of the community events that we attend. And he's got a great outline of what's going on with Via Space, our hometown company that uses recyclable plastic for their fuel. And that's
Yeah.
something that you've been working on a long time.
We have. It's high density polyethylene. So it's 99% recycled plastic. So every time we launch, we take about 7 or 8 metric tons of recycled plastic off the planet. So we're
Okay.
pretty proud of that. Greenest rocket company on the planet for sure.
And it's the only rocket company in the state of Florida. And we love talking about that. I'm bringing you all up here on our on Facebook. Hope everybody can hear us loud and clear. Let's see, we know there. I see we're heard all the way from Colorado. Mitch Rothman's watching us today. And Kevin, we got a whole social gathering of people that love watching this at 4 o'clock from around the world. So we'll be giving them a shout out here. And if you've got a question to Kevin, please, give just write it in there, and we'll get to that there. So, but I always like I got Via Space. There's their logo. You've gone through some different looking logos there. Wanted to talk about that here just a minute. But before I get into a little piece of space history too, um, going on today, not space history, but aviation history. I love asking my guests, Kevin, where'd you grow up? How'd you get into this rocket business game? What's
Great
your
question.
background?
I grew up in Indiana, small town in Indiana, southern Indiana,
What town?
farming town, Monrovia. So Morgan County, Indiana, between Indianapolis and Bloomington.
Okay.
Real small farming community, 111 people in my graduating class.
Oh, okay.
So I had my bedroom was Apollo, everything Apollo in my bedroom from the time that I can remember, having a bedroom. So I was always interested in the space program. I ended up going down a path that put me into aerospace and defense, but not into space necessarily. So I worked for Rolls-Royce for a little over 20 years and migrated to Florida
Now, Rolls
over
Royce,
time.
people think of the car,
Yeah,
but they're
no,
really an
yeah.
engine. What part
Yeah.
were you of it?
So it was the aerospace and defense piece of Rolls Royce. So I had, at different points in my Rolls Royce career, responsibilities for both defense applications and aerospace applications. But their commercial regional jet and corporate jet business was under my control for a while from a finance perspective. And so a
Uh-huh.
piece of that business in Germany, a piece in the UK, and a piece in the US. And we split that up, and I migrated to the headquarters office in Washington, D.C. for a number of years before coming to Florida. And I came to Florida a little over 10 years ago, and I've been with Vaya Space for a little over 4 years now.
Hmm.
I tell people my background's operations and finance. We have some really, really brilliant engineers. I'm not one of them.
Well, those brilliant engineers need a lot of money to be so brilliant. And it certainly sounds like you're the right guy connected with the government stuff, red tape. Anybody involved with defense contracts and so forth has a different perspective on everything. And I know that's a huge part of Via Space. Their Dauntless rocket, he's going to talk in detail about it, has a very unique feature that it can be started and stopped.
Yeah.
And that's a game changer in the rocket business, solid fuel business particularly, right?
hmm It is both for space applications and for defense applications.
Mm-hmm.
That capability just doesn't exist elsewhere.
Yeah, and
Yeah.
we're glad
hmm
of that. Well, good. We got the usual people. Cliff Watson's down in Pomona, Australia, buddy. Hope you're doing well. How's your brekkie on Friday? I can't wait to get to Friday. This is only Wednesday. Okay, that's actually he's down there on Thursday. So we'll have some great comments there from our regular people. I did want to interject a little juxtaposition of history here as we look at Kevin's picture there and the Via logo. Kitty Hawk, A lot of people know what happened to Kitty Hawk, and that was on this day in 1903,
Mhm.
122 years ago. Yeah, when these two brothers, one of the most famous pictures ever taken with the camera there, and from Dayton, Ohio, both Ohio and North Carolina fight over the rights of who's the first in aviation. But I think we all know 24 astronauts come from Ohio, and I'm a Buckeye from Findlay, Ohio.
Okay.
Okay. I listen to Whoa Whoa a lot, though, as a
You're a
kid.
little one-sided there. I
I
think,
am a
is
little
it?
bit one-sided there, yeah. Well, you got your Purdue knots too up there
Yep.
in Indiana,
Yep, for
okay,
sure.
and everybody loves where Gus Grissom grew up in Indiana, and I got so anyway. This is history going on today, 123 years ago, and we're going to talk about this bad boy here. And I'm not sure what conception this is. This rocket companies are always changing some of their things there, but your rocket's called Dauntless there, and there you see the beautiful artwork there. Go to their website there, and how did Vaya get created there?
Yeah, so Sid is really Sid Gutierrez, first Hispanic-born or U.S.-born Hispanic astronaut. It really is the founder of the current iteration of Vaya Space, and it's called Vaya Space particularly because of one of his shuttle missions. Via Space, when they launched, typically they would say, you know, Godspeed, and they determined that they weren't going to say that anymore. And he had a little agreement with Bob Seek, who was on the control panel. And when they launched, he said Vaya con Dios, and so Vaya became the genesis for Via Space. Via meaning go, and to space, Via Space.
And I've met him. He's from well, I've been hanging around you guys for over 3 years. He's really a hands-on
Yes.
guy. Who doesn't love to come to Space Coast? Not sure where he lives. Where does he live?
So he's in Texas mostly.
Uh,
He's got a place in New Mexico as well, and we are really lucky to have not only him but the full board be as aggressive and inclusive in everything that we're doing. And we've got a couple of guys who are 4-star generals on our advisory board who really help us on the defense side as
Yeah.
well. So yeah, we're lucky to have
Yeah,
the whole
look
group.
him up on the website,
Mhm.
and that permeates down to your whole staff and everything. There's the Dauntless rocket and the Green Rocket Launch Company, showing fearlessness and determination is the definition of Dauntless. And there's your team in there. When I saw that picture on your website, I got to show that. That's so cool. I've been in your building and so forth and know where that's taken. And it's definitely a 21st century company. People bring their dogs. All right,
We do.
your dog
Yeah.
friendly. Your commissary is kind of an honor system type of thing. They got your pool table, ping pong stuff like that. That I think's I wish we had that in some of our places I worked. It seemed more like sweatshops than a place to work.
That
But
was an interesting conversation for our team. They came to me or came to us and said, "Hey, look, we can either go home and take care of our dogs, or you can let us bring our dogs to the office and we can stay a little longer." So we're happy to have the dogs, be a part of Via Space, and they are definitely a part of.
I count
What we
about
do.
3 dozen people there. What? How many people is involved?
I was
in the
going to say
company?
we need to get you a new picture. We're up to about 85.
Okay.
We purchased Via Advanced Machining earlier this year. That brought in about 12 just in that acquisition to do precision machining for us for some of the components that we're working on. But that brought us up to 85 today, and we're looking to grow even further, particularly based on the programs that we've gotten assigned to us from.
Kevin, I was at
the-
that ribbon cutting with that machine shop, and I
Mhm.
think it's a good story that our Stay Curious viewers hear of some of the risks that a startup company like you need to take. You need to have things tooled specifically the way you want. So that's something that maybe you want to outsource. And so you found a local company and tell them what you did to prove their mettle.
Yeah, they didn't know it at the time.
Yeah, this is
So-
good, man.
So we 3D print a lot of our components, and in the 3D printing process, you need a lot of post print machining, and so we sent them a component that was our injector, and our injector is about a $250,000 component. Really tight tolerances. and gave it to them to machine for us without telling them how much it
Of
cost
course, a
going into
quarter
it.
million dollar part.
And they did a phenomenal job. The team there is amazing. They really are good at what they do, exceptional at what they do. And so that went very well. We had some other things that we gave them to machine. And ultimately, one of the big problems you have for a company like ours is supply chain is not very robust. And so you can get those parts 3D printed, and they wait in line for a long period of time before you can actually get to the point where somebody can machine them for you. So picking that company up and having them on site or on side to be able to do that work for us really helped us from a supply chain standpoint.
Yeah, I just found that interesting. A quarter million dollar part, we're going to trust them with it, see if they can machine it right, and then you end up buying the company.
Yeah, yeah,
All right.
that's exactly the way it happened.
Yeah, and that's how it happens in the space world. Okay, also layered in there is things are a little bit proprietary because this is a competitive market,
Mm-hmm.
so you don't want your ideas broadcast to somebody else. So
Yeah,
you've got that element in there.
yeah.
But you working with the Defense Department, you got all that covered, I'm sure, in there. But no, I find that very interesting and so forth. Before I turn him loose on his program here with Kevin Lowdermilk, want to just say yes, Rob Fabian, your COO. He's been on Stay Curious before and participated
Mm-hmm.
in our Shuttle Fest on a panel there. I've gotten to know Rob since I was in his office when you were down at Cocoa Village
Mm-hmm.
up there. He and Rob's comes from the military also, the MX missile world, I believe, out there.
Yep.
He had something that was in one of the silos on his wall there that I liked, like a sheet of a silo out there.
He worked ICBMs, yeah.
Yeah,
So he was.
yeah. And then just a few of the people that we've had on here, Catherine and Michaela, talking. What were these girls experts? Systems engineer and a propulsion engineer there.
Mm-hmm.
Keith and Giovanni. Giovanni, he's a brilliant young man. Go back and look at some of these when you're bored with the in-laws outlaws over the holidays there, and you'll learn about they're to me they're just like all the other engineers, the other companies. They're smart. They got great innovative ideas, and they're taking our American space program into places that we never envisioned, really, maybe.
Yeah. These guys are today. Giovanni in particular is working laser ignition testing on one of our applications to dial it in before we go out and test some engines. So,
Okay.
yeah.
If you got a plastic fuel, that's hard. How are you going to ignite that and keep it to burn? All right. And Giovanni kind of came up with the solution to that, didn't he?
Yeah, he did. And hybrid engines are notorious for being difficult to start. And so laser ignition proved to be the best way to get it done. And Giovanni's just been brilliant in getting it done.
All right. We got a question already, Marty. That's all my PR up front there. Now let Kevin uh, uh, share with us his program. Yes, Marty.
Yeah, Michael Bruno is asking, how big are your 3D printers?
Yeah, so our 3D printers are coming from Velo, and so it's Velo Sapphire XCs are the machines that we use. At this point, we're using Velo's machines. Those machines are really expensive, and the largest, the bed has to be really large to be able to do our injectors and our nozzles for the Dauntless rocket. So at this point, we outsource that particular piece to them, but it's the Velo Sapphire XCs that we use.
We're going to see examples of that here towards the end in some of the 3D printing. So Kevin, there's your program there, buddy. Just tell me when to advance it there.
Yeah, go ahead. So at a high level, Vaya Space is a space and defense company. We're leveraging patented hybrid engine technology to really make some pretty incredible advancements, both in the space applications and in defense applications. And I'll take you through some of those. Hybrid engine at its core is a liquid oxidizer, a control valve between the liquid oxidizer and a solid fuel grain. You open that oxidizer valve and the oxidizer feeds into the solid fuel grain, ignited by that laser ignition system we were just talking about with Giovanni. And that's how we get combustion. So typically the rockets that are going to launch are going to be liquid oxidizer, liquid fuel. We put them together, you get combustion. Ours is separate, liquid oxidizer, solid fuel. Hybrids have been around since the 30s. Nobody's been able to figure out how to get the performance and the power out of a hybrid engine to really either get space to lower or payload to low Earth orbit in space, or to replace solid rocket motors in defense applications. And we've been able to do both of those things at Vaya Space, leveraging some patents. So I'll let you advance there. I think I probably hit on that slide as well. Yeah, and so one more.
Oh.
Yeah, so the way we do it, on the left-hand side, the typical hybrid engine, what you see is you open up that throttle valve, and the oxidizer flows into your fuel grain, right down through the middle of the fuel grain and right out the back end, and you lose all your performance and power with it. What our team did was create a vortex injector, which really does exactly what it sounds like. Creates a tornado down inside that fuel grain. It's on the front end of the engine to create that tornado, and it really allows us to keep the oxidizer pressed up against the fuel grain wall all the way down through the fuel grain, whether it's a small one for defense purposes at 3 feet long or one for our Dauntless engines, which are 22 feet long and 3 feet around. So we get good, even, stable burn based on both that patent and another patent we use for laying down the fuel grains. That's what makes us different and unique. We've been able to figure out to harness really the power of a hybrid where others have not been able to do that. On the space side of things, what we say is we don't perform better than liquid bipropellant powered rockets. We perform equal to liquid bipropellant powered rockets with 1,000 fewer parts, that much less cost, that much less weight, meaning we can take that much more payload to space. So the economics of our rocket are far different than our competitors. Most of our competitors are looking at, hey, how do we get reusability into the mix to allow us to reduce costs? We just went with what we call an elegantly simple approach in the first place, which puts us in a position where we don't have to be so conscious about reusability. The economics on 1,000 kilograms of payload for us are very, very good. That's where Elon would have started, right? He started with a Falcon 1, about 1,000 kilograms of payload. Realized pretty quick that given the liquid bipropellant complexity, he had to go bigger in order to make the economics work. Now he's done that, and he's done it very well, and things have worked out well for them. But at this size class, it's really hard to get a liquid bipropellant to do what we can do.
Okay.
So. So that's the space side of the equation. So our mission set on the space side of the equation, just to kind of top that off, small constellations and replenishment missions. So everything that goes into low Earth orbit is coming out of low Earth orbit in about a 5 to 7 year window, just based on the drag in the atmosphere and where it's placed in low Earth orbit. All the satellites need to be replenished, and where you want to replenish them is not where they were originally launched from, but where they are in the constellation. So you really need the capability of our rocket, that start-stop capability, that throttle capability, to be able to put the satellites into the precise orbits where they need to be, when they need to be there. And so the guys who are building out the bigger constellations are coming to us saying, look, we got a ride to get the satellites up in the first place. What we need is a ride to replenish the satellites that come out of service over time. That's where we sit in the market that we serve. So our market never gets smaller. Every satellite that goes up is ultimately going to come down, so it's always going to be growing in total. And so it really puts us in a good spot from a market standpoint.
We'll talk about when they're going to launch and things like that here in a minute, but define for people that might not exactly have a handle on it what low Earth orbit is defined as. LEO.
Yeah, so LEO is it's the lowest area of range in terms of where satellites are predominantly going to go. LEO is where most of your observation satellites and those things are going to be. They need to be closer to Earth in order to be able to get the signals back and forth fast enough to be able to make use of the transmissions that they're providing. So LEO is just closest to the Earth, but in space. Is the way we think about it. It's a pretty broad range. 550 kilometers is kind of where we tend to think about our mission set.
Okay, the 300 miles, 550 kilometers, that sort of thing. Where the International Space Station is and what we've called space in the last 53 years, and basically is low Earth orbit, and that you can go up higher, and then of course your geo orbit up there. But you're basically concerned with the low Earth orbit. In talking to you and other leaders there. There are a lot of companies, a lot of clients lined up, waiting for your company and even others to start cranking it up, right?
Yeah, you ask about when we launch. Right now, the expectation is that we'll launch at the back end of 2028. We're launching off of Launch Complex 13, which is where SpaceX lands their boosters today. The environmental work is being done for us out there now, and as soon as that's done, we'll transition from SpaceX to Vaya Space in order to build out the infrastructure that we need to be able to launch. our initial customer, the largest one we have anyway, is building a constellation around the equator to provide 5G service to that part of the world. So it's for us going to be 12 to 15 missions starting in 28 and going until we're done. And when we're done, we'll be at the point where they're probably going to be replenishing the satellites that they put up in the first instance.
Yeah.
It's kind of just a revolving market opportunity.
Excellent job security.
There you go.
You had a big announcement a couple of weeks ago about launching capabilities. Can you share that with us?
Yeah, so
Offshore.
Yeah, we're able to launch off of Launch Complex 13. It's very clear that Cape Canaveral and the Space Force, there's going to be a bottleneck there, and so we're working to be in a position where we can launch offshore, and really thinking offshore Florida, to both be able to get to some orbits that we can't get to off Cape Canaveral. And also be able to manage the kind of cadence that we want to be able to manage. We're looking to go about once a week. Ultimately, it'll take us a while to get to. It'll take us a while to get to that cadence. But when we're doing that, given how crowded Cape Canaveral is going to be, we're going to need to have some options. And for us anyway, we think Florida is the right place to do that, and we'll do it from offshore.
We had a historian and PAO person, Bob Granath, on yesterday, and Bob did a show basically about how Bob Cabana and Janet Petro were keys to bringing in the private industry at the end of the shuttle era there, and one of the questions was how many launches can the whole thing support a year, and with it being safe and the range and all that sort of stuff, because we just had this morning our 109th launch. As I saw another Falcon 9 take off. I watched one last night, too. Okay.
And Starship's not here yet.
Yeah, and Starship's not here yet. And it seems like about 145 is what I've heard people talk about. We see Rob Long of Space Florida talking, other people, they're starting to kind of say, like, there might be a limit to what we could do here. What are you hearing? What can you
I think that's absolutely right, which is why we're thinking. I should have mentioned that partnership that we opened is with a group called Seagate, and they're building offshore capability.
Seagate, okay.
Yeah, they're building offshore capability for us to be able to launch.
Autonomous, too.
Yeah.
Autonomous drones.
And our rocket is what we call elegantly simple, so it's really well suited for those, for us to be able to partner to get that done. But one of the things you have to think about is early on when you're launching a new rocket, the exclusion zones are pretty big around your launch site. So when Starship comes to town, there'll be a pretty big exclusion zone around what they can do, which means that everybody else is, while they're doing that, not going to be able to launch. So it's definitely going to limit launches, much like the exclusion zone will be pretty broad for us when we first start launching, and then it narrows down based on your experience set. So yeah, it's going to be a challenge for sure, and one that we're hopefully out in front of a little bit.
I hope you're enjoying this conversation with Kevin Lowdermilk. He's running one of the cleanest companies around. The plastic, by the way, that they recycle, I understand, is not like the bottle plastic. It's more like the cap of the plastic bottle. Is that correct?
Yeah, it is. The density is bottle cap density. It's high density polyethylene is what it's called. It comes to us in pelletized form. So it comes to us in pellets. We load it into the hopper, melt it down, and then lay it down on a rotating mandrel horizontally to be able to build the engines that we build. But we're by far the greenest rocket company. In addition to taking that much, 7 or 8 metric tons of recycled plastic off the planet, our emissions are CO2 and water vapor about 96%. So there's still gases, but in terms of the most hazardous ones, we're in good shape there as well.
Well, here's a slide here. We're going to see a little more of your facilities too here in a minute. There's in the upper left-hand corner, that's actually the engine, right?
That's a Hellfire missile engine, our version of a Hellfire missile engine. So
not very big, folks, right?
No, these things burn for 7 or 8 seconds. Is the full duration burn on one of those things, and they're solid rocket motor powered. We went to see the Army, and we told the Army, hey, look, we think we got a better mousetrap. We can start, stop, throttle our engines. We're also inert, so from a storage, handling, transportation standpoint, you're going to be better off. And they said to us, hey, oh, that's great. What we care about is range, range, and range. How much range can you give me out of your new missiles? And it turns out that our engines go about 35% further then a solid rocket motor will go in a particular application. So those tests you're looking at there on the slide that is in front of us. On the left side is our throttle test. We did this for the Army. We've done now 30 or more than 30 tests. The throttle test where we'll go at 100% throttle it down to 30%, I think in this instance, and then throttle it back up to 30 on the left-hand side. And then on the right-hand side there, stop and relight. We lit the engine, ran it for 5 or 6 seconds, shut it down, and then lit it again and ran it for about 10 or 15 seconds, and then ran it again for another about 6 or 7 seconds. So that capability being demonstrated has allowed us to really accelerate what we're doing on the defense side of our business. And the defense side of our business, I don't have much more in the slides there on that, but the defense side of our business, what we're doing is working with prime contractor to put our engine in a Gimler's missile. Gimler's missiles are produced at a rate of about 10,000 or so a year. They'd like to get to 20,000, and one of the big reasons they can't is because solid rocket motors are difficult to produce. You got to produce them in an explosives factory, given the nature of solid rocket motors. So we're in a position where, again, with the capability that we have, we can really ramp up quickly, and we're working with the prime contractor. We're working right now on subscale testing. So we're out in California with the team doing 20 to 25, I guess, engines at a subscale, and then next year we're going to do 20 to 25 full-size engines. We want to fly a Gimler's missile with our engine in it at the end of next year, and then go into production in early 2027 for that particular missile type. But really, any missile where range matters, surface to surface are probably the best ones. A hybrid engine in those missiles is going to do much better.
They're rounding second, going into third base here, and your scale there, because we're getting close, and it's going to be exciting.
We've got.
Yeah, go ahead.
Yeah, I'm sorry. I was just going to say we've got a couple of programs that we're working that are really, really interesting programs. Everybody talks about hypersonics and the need for hypersonics weapons. So a hybrid engine is really well suited for hypersonics. So we're working on a phase 2 program with the U.S. government to really prove out hybrid capability in a hypersonic, and that's going well so far. We've got more work to do there, certainly, but at least so far what we're doing is working out well, and we think we've got something that should make a lot of sense. Typically it takes 2 engines to do that, one for boost and one for glide. We do it the full mission set with one hybrid engine, so it's much simpler, much more cost effective, just as capable. So it's interesting. There's another program that the government's got us working on. They want to really be able to build engines, sit them on a shelf, and then right before the mission set, plug them into the missile body and dial them in for the particular missile type, and then go fly. Solid rocket motors can't do that, but because we can start, stop, throttle, our motors are really well suited for those kind of applications, and we're working a phase 2 program now, just really kicking it off for that application.
Excellent. A lot of optimism, a lot of good stuff going on at Vaya Space. Marty, we've got a question for Kevin.
Here, a question from Steve Holcomb. Is Vaya Space operating from a renewable energy source, such as solar or wind?
No, from a facility standpoint, no. Our green claim to fame really is in terms of the way that we handle the rockets, and we are to kind of follow on that point. We're going to take the first stage out of the ocean as well, not necessarily because we think we're going to be able to reuse components from the first stage, but because we think it's the right thing to do from an environmental standpoint.
Okay, so this is not a reusable first stage, but you're going to harvest it anyway, so that it's not left there. Yeah. Good. I don't know too many other startup companies, but you've had a growth rate mushrooming out. I think, Steve, part of the answer to that question, knowing them, is like you've been at a different few locations. Mm-hmm. Not sure if where you're at right now be your final location. Maybe once are you envisioning building a facility from scratch somewhere where you would probably have solar panels and things like that?
Yeah, I think when we go to look at final destination for some of what we're doing, we'll do it as green and efficiently as we possibly can. But we don't have that capability today. We do use solar power out at our test site and anywhere we can. But I wouldn't want to suggest that
Yeah.
we're completely transformed there. Yeah, we can build
You
about.
found existing facilities to,
Yeah,
to do
and
to,
that's
to
where.
operate in. So, to be all fairness, Steve, they want to be green, but they've leasing or buying existing facilities to work in there and retrofit them back later there.
Yeah,
So,
where we are today, I think that's probably the next slide coming up
Yeah.
in the slide pack.
yeah, here we go.
This is our headquarters facility. We can build about one rocket a month out of this facility. We need to be at one a week. So just to do the Dauntless launch vehicles, we're going to have to grow very substantially. And then when you think about the kind of volumes, we've been asked to see how quickly we can ramp up to 6,000 engines per year for the Gimler's missile application. We're going to have a whole new facility to be able to manage that kind of volume.
6,000 missiles a year.
Mm-hmm.
Oh,
And that's a small fraction. They want to get to 20,000 in total, so they want to get us to 6,000, and then look at our performance, and then change that mix based on how we perform over time. So we'll grow beyond that, but at least the initial ask is how quick can we ramp up to 6,000.
well, there's their campus now. And
Yeah,
then some
so the top piece is inside that engines. We do our engines, our tanks, and our vehicle assembly in that building that you're looking at in the top left. And then the bottom side of this, from a manufacturing standpoint, is where we do that high precision machining. That's Vaya Advanced Machining. We picked that facility up earlier this year. Very, very capable machine shop that we do both our work in, and we also subcontract out. Probably 70% of the work that's done in that facility is not ours. 30% is Vaya Space work. So test facilities. Both of these facilities also within about 3 or 4 miles of our headquarters facility. On the top side there, you see we can test about 5,000 pounds of thrust in the facility on the top side. Anything more than that, we need to go out to the facility you see on the bottom, where we can test up to 35,000 pounds of thrust. The Gimler's missile engine I referenced is about 7,000 pounds of thrust, so it's going to need to be tested in the bottom test facility, along with our Dauntless engines, which are just under that 35,000 pounds of thrust.
This is all in the city limits of Cocoa, Florida, and not to be confused with Cocoa Beach, which took a while for me to get straightened out.
Mm-hmm.
The beach is about 30 miles to the east, but you've got some great partners with the city of Cocoa.
We do. We have a great relationship with them. We're very open with them. They come in and visit whenever and whenever and however they want. And whenever we're testing anything of any significance, they know that that's coming. So they've been great partners, both the county and the city.
And you're going to make some noise, and they know you're going to make some noise. So you're going to warn everybody when you're doing a test, I understand.
That's exactly right. We have a pretty good warning system, both for the small facility and for the larger facility when testing occurs. And we've got restrictions on when we can test those to make sure that we're not waking people up in the middle of the night with tests. But so far, so good.
Right, yeah. Great in there. And then here's the launch pad situation, which was the old LZ-1 that SpaceX used to land, I don't know, 400 and some first stage boosters.
Yeah, they've landed a good number of boosters there. This is an older picture of the rocket row when it was out there. The last thing that lifted off of the pad that we're going to be using was an Atlas rocket back in '78. So we've got a lot of work to do to get the infrastructure in place to launch, as opposed to to land a booster. But it's going well so far, and we've got a good relationship with SpaceX as we do that transition.
And there's this will never look the same. This rocket row, I guarantee it. It's I know there's I've seen some plans from the NASA side and Cape Canaveral side. They're talking about a bigger runway and all that stuff in there where the skid strip is.
Yeah.
But you need facilities there to make gases, water facilities, blah blah blah. It's going to be quite a transition, don't you think?
Well, it is, and it's underway. I mean, you mentioned Rob Long. I wouldn't want to have his job looking at everything that's got to happen on the Space Coast right now and trying to get it all integrated with all the people who are.
Yeah, Rob Long is Space Florida. They took over for Mr. DeBillo, who's been there many years. They've got state money to bring in the companies and make them happy here. So that's good there. So. And then here's some of the 3D printed things that you...
Yeah, I just want to show off a few of these. Somebody asked about, how big a 3D printer do you need? You need a printer big enough. The Velo Sapphire XC is required to be able to print that the injector on the far right, which that's patented for us, that's made out of Inconel. The nozzle in the middle is a copper alloy, GR copper, and then Inconel on the left-hand side with our turbo pump. All of those probably couldn't have been made 5-6 years ago. You can't subtractively make any of those parts.
Wow.
You have to 3D print them, and the print beds weren't large enough to be able to print in these kind of metals at that size even 4 or 5 years ago. So the technology is really just catching up with what our engineers have been able to design.
Just amazing cutting edge stuff going on at Vaya Space. There's your oxidizer tank.
That's our first stage oxidizer tank. Again, a pretty unique. It's composite with carbon fiber overwrap, so there is no liner in that tank. No steel, no aluminum liner. Takes about 30% of the weight out, which again means more payload to space, and that's the equation we work on a regular basis.
Mm-hmm. And there's Prometheus. You were asking about how big a 3D printer is. That's those doors are. You can walk in those doors, right?
Oh yeah, and we do regularly. That you can see a fuel grain being printed on the bottom left there. That fuel grain is for the Dauntless launch vehicle, about 22 feet in length and 3.5 feet around. Yeah, right there.
Yeah, that's it.
So we can produce the smaller ones that'll be defense size all the way up to, that's about as large a print bed as we've got for about 22 feet.
Excellent. I could. What a great look at one of the companies. It's going to make a big impact and a big difference. And when you've got the military contracts going on with this start and stop capability there, there's going to be some big news here in the space world there once they get launching here. Marty, go ahead.
Yeah, Carlton Bailey is asking, is testing near the home office? Should my neighbors and I anticipate hearing rocket motors? And he says, I enjoyed, don't
He
get
lives
me
in
wrong.
Canaveral Groves.
Yeah, yes. I think the answer is yes. And if you want to come and see one and witness one, happy to have you in the control room at some point so you see what we're doing. We won't surprise you. We'll do our best to make sure that the communication's out there when we're launching or when we're testing. But yeah, I expect you probably will be able to hear the engines test.
Great, good. I've enjoyed Kevin being here with us here. I threw a couple extra pictures in there. There's a little bullpen talk. Kevin standing there. One of the tours that I've been privileged to enjoy over there. Want to say hi to Dave Stange, RG Jubilee, watching. Dave's up in Michigan. Rosalie's in Merritt Island. Mostly Parks watching. Keith Sewell, my astronomy buddy in Arkansas. Gary Gerald, he is our Vidalia onion farmer in Georgia, Kevin. I'll get you some when he brings us some in there.
Sounds good, please.
Look at this picture here. There's Rob Fabian there with Sid Gutierrez and two legacy people that, of course, support our museum and support you, Mr. John Tribe. There next to Bob Seek. They're the great, both NASA legends. Bob launched the most shuttles, 51. But he was involved with the program in Gemini. When they called him Bobby.
He launched both of Sid's missions. Yeah. That picture's taken out at our large engine testing.
In there.
Yeah.
So Jesse's watching. My daughter Jessie didn't catch that. With my granddaughters watching. We'll be seeing you guys next week. Steve Jokums is up in Fox Lake, Illinois. Cliff Watson's down in Pomona, Australia. Tom Celentano. Hope you enjoyed this look at a real space company behind the scenes.
I do want to just quickly apologize for us being a few minutes late. The American Space Museum is amazing, and I'm a kid in a candy store, and I was getting the tour. So if you get an opportunity to come see it, you definitely should. I enjoyed it. Thank you for doing that.
Well, you're welcome. You're welcome. You're welcome. Well, we feel we can talk about the museum, but I keep saying they got to come inside of it. You got to see that we have an intimacy, a provenance of what we're displaying like none other. It's just incredible.
It's been awesome. Thanks.
You're welcome. You're welcome. And I can't wait for Sid to see it here. And I hope he enjoys that picture that he got to see.
He's already seen it. Yeah, he's already seen it.
And there we had a big picture in our break room of his crew. Tom Usiak, he photographed one of Sid's launches, probably both of them as a photographer. He's in Pennsylvania. Michael Bruno in Miami. Fox McCloud watching. Chris Calley. Hey, Chris, buddy. and Doug Forrest, both fabulous artists. Chris has done over 40 U.S. postage stamps, and he and his dad did some of the Apollo moon stamps. Paul and Chris Cowley. So, yeah, thank you so much. Is there something I didn't ask you that you'd like to share, Kevin?
No. I think we've covered it. I think from a team perspective, if you get a chance to come see us and see the facility, for those of you who are watching and you're in the area, we're happy to show you around. We've got some really brilliant engineers. They can tell the story a heck of a lot better than I can. So
we've had a half a dozen of them on here, and they do. I've always called up Mary, your PR person, and said, Mary, these kids are so literate and so into what they're doing, and everybody can see it. And you got a great team there. So, Kevin, thank you so much for taking your time to come here, and all of you taking your time to watch today. Thursday, we'll catch up with some space news. I still want to dig deeper into that window that was cracked on the Chinese spacecraft, that they did a spacewalk and looked at it.
Yeah.
All right. And we'll catch up with space news and space history like we do here on Stay Curious. And then Carlton Bailey will be here, our favorite launch photographer locally here. CB will tell some tales over his 40 Decembers of watching launches here. Marty, anything else over there?
Yeah, Carlton is saying that, I just lost it. He's within walking distance of Vaya Space. He's a photographer, and he'll probably contact you about talk about his credentials.
Okay,
if you need someone.
He's welcome anytime. Love to talk to you.
Yeah, I've just got to notice that Isaac Mint has been confirmed.
Awesome.
Another good question from Mostly Parked: is the fuel and processes patented?
Yes. So the fuel itself is not patented. The process we have for laying down our fuel grains is a patent that we hold. We hold 3. We hold 1 for that vortex injector. We hold 1 for the way we lay down the fuel grains so that we get combustion stability. And the last one is to prevent slosh. We have that 1 tank in the center of 6 engines. So our engines are mounted externally to the tank. And depending on the vehicle attitude, you run the risk of having slosh. And so we have a slosh protection patent to keep the engines fully loaded at all times. Yeah.
Excellent.
We have about 5 more that are running their way through the system, but those are the 3 we currently hold.
How many hours does it take to print one of those rockets?
So to print an engine, the 3D printed the engine piece of it right now takes us about 4 days. It should take us about under 24 hours when we get it to full scale. It's an undertaking. We do it layer by layer to build it up to about 3.5 feet, 4 feet around.
Excellent. Well, good. Well, thank you again, Kevin. We really appreciated it. I see Woody M2. He said when he visits his sister in St. Augustine next time, he's going to make the drive down here.
Awesome.
Just a little under 2 hours. It'd be well worth it there. I love going up there. The excuse to go up there.
Yeah,
so, again, thank you so much, Kevin. Can't wait to see you
you
around some different tables in the community here. And we will be sharing Vaya Space news and get a couple of your engineers on here after the first of the year to share some of this exciting breakthrough technology that is going to change the landscape of the space age. And that's what we represent here at the American Space Museum, is the birth of the space age, where companies like Vaya Space now are becoming so ingrained in what we're doing and necessary for how we're doing things. So with communications and so forth. So thank you all for watching. I'll be back tomorrow. I'm Mark Marquette, and I can't wait to see you in our museum, like Kevin, to bridge the space between us.
It's a wrap.
Awesome.
All right.
Awesome. Thank you.
You're welcome. You're welcome.